Today I'm going to talk about direct proportion, and all direct proportion is that it's a ratio between two things. So if I'm given one value, I can work out a second value. So what I'm going to look at to start off with before we introduce it is just to think about an example. When Mo Farah runs for 8 meters per second for some distance of time, we don't know that time, he covers 240 meters. Before doing anything about proportion, we can actually work out how far he's going to travel if he runs at twice the speed. Because if something travels at twice the speed, it's going to cover twice the distance. So to get from 8 to 16, I have to multiply by 2. So 240 multiplied by 2 is 480 meters. I'd like to think about what is it going to be, well, how far is he going to travel if his speed is halved? Because from 8 to 4 we halve it, so therefore the distance would halve. And lastly, from 8 to 24, what's the relationship? So what's going to happen to my distance? And hopefully we should have got an answer of 720 meters. We're multiplying by 3. What we're saying here is that these things, speed and distance, are linked in some way, and all that proportion is trying to work out what is that link between them. So the easiest way to think about this is, how far do I travel if my speed is 1 meters per second? So at 1 meters per second, how far am I going to travel? Well, if I travel 120 meters in 4 seconds, at 4 meters per second, I can divide them, and I would get that for each meter per second, I'm going to travel 30 meters. So how does this help me? Well, let's think about this in terms of, if I've got some distance, what is that in terms of its speed? And we can link them with an equation. We know that as speed rises, my distance will rise. And if my speed decreases, my distance will decrease. That means that they are proportional. My distance is proportional to my speed. This value here, all that means is proportional to. And what we can do is, if we want to turn this into an equation, we know that there's some scale factor between 8 and 240, so therefore my distance is going to be equal to some scale factor times the speed. In my example, I've worked out what my scale factor is. It is 30, so I could say my distance is equal to 30s. So how far I travel is equal to 30 multiplied by my speed. And let's just check that. 24 to 720 I times by 30, 4 to 120 I times by 30, and so on. So this would be an example of direct proportion because we have some multiple scale factor. So looking at a question, these are two types of questions which would be given in an exam. I'm just going to go through how we would answer it. So I would read the first line, and it says y is directly proportional to x. So the first thing I'm going to write down is y is directly proportional to x. So therefore I know I can get rid of that proportionality sign by multiplying by some constant. So this is the same as writing y equals kx, where k is just some value that I need to work out. I know that when x equals 3, y equals 7.5. So what I can do is, when x is 3, y is 7.5, I can just swap these values around. Y is 7.5, so I can say 7.5 equals, k hasn't changed, and x is going to change to 3. So therefore, I can work out what k is by dividing by 3. So I can say k is equal to, and it'll be 7.5 divided by 3, which will be 2.5, or 5 over 2. So now I'm going to rewrite my equation with this value of k in. I know now that k is equal to 2.5. So therefore, in this equation here, I'm going to swap in my 2.5. So just so we're going to be clear, I've done this step to work out k, so I'm going to say y equals 2.5x. This means, similar to my example for speed, whatever my value of x is, if I multiply it by 2.5, I'll get the corresponding value for y. So when I'm told x is 4.4, I can say y equals 2.5 multiplied by 4.4. I can work that out. 8.8 add 2.2 is going to be 10. Why can't I add that up? 11. So y would be equal to 11. And that would be the end of the question. I found a formula for y in terms of x. I found that in this scenario here. This is my formula for y with x. And I've substituted in 4.4 and I've got my value for y. Okay. The only way this differs slightly is for when we have something which is proportional. However, we need to check what this is actually proportional to. And it says y is directly proportional to the square of x. So if it's directly proportional to the square of x, I'm going to write down y is proportional to x squared, because that's the square of x. So when I replace that proportionality, it's going to be some constant multiplied by x squared. So I do the same thing now. I'm given a point, I'm going to substitute them in. X is 3, y is 36, so I'm going to swap them for these two values. So y is 36, and that's going to be equal to some multiple, and I'm going to put this in brackets because it is 3 squared. So 36 equals k multiplied by 9, therefore dividing by 9, k is going to be equal to 4. What I can do here, again, I know that my value of k is equal to 4, so therefore I'm going to replace it with this equation. That would give me y equals 4x squared. I want to find the value of y when x equals 5, so I'm going to substitute in x equals 5. So it's going to be 4 multiplied by 5 squared. So y is going to equal, well, 5 squared is 25, times by 4 is 100. Okay, so that is direct proportion. What I'd like you to do is have a go at these questions here, please. Pause the video, and then I'm going to show you the answers. Okay, so just going through. The answer to the first one, y equals 4x, y equals 0.5x. We should get a value of b equals 16.25, 12, 40.5, 12, 8, 125, and the final one, I've shown my workings out. Y is directly proportional to x squared, therefore y is equal to kx squared. We substitute in our values of 405, we get k is equal to 16, so therefore a formula linking them with y equals 16x squared. That comes to the end of the video. I hope you found it useful. If you have any questions, please feel free to email me, and hopefully I'll see you in the next one. Thank you.